In the dusty outskirts of Kigali in 2024, a brand new mobile clinic hummed with a mix of hope and nervous energy. The team believed they were witnessing the future of healthcare. At its heart was a single AI agent, a supposed marvel of engineering, tasked with managing the entire operation alone. It was meant to diagnose diseases, book appointments, order vital medications, and even train the local staff. But that future lasted less than 48 hours. The system crashed, not from a simple bug, but from the sheer crushing weight of its own ambition. It was overwhelmed, inconsistent, and dangerously unsafe. Why? Because we had asked a single digital mind to do the work of an entire human team. Today, I'm going to walk you through Phase 8 of the 10-phase journey to Master Agentic AI, create multi-agent systems. This isn't about making AI more complicated. It's about making it smarter by making it more collaborative. Building AI teams that work together with the same clarity, role separation, and mutual accountability we expect from human experts. I'm Marcel Masaga. I'm an AI engineer and a 5-time founder. For over 20 years, I've been on the ground building real-world AI systems. I've seen what works and what fails, from diagnostic tools we deployed in rural East African clinics to bootstrap startups that earned global recognition. I've sat on 5 global AI ethics bodies, all in pursuit of one question: how do we build AI that doesn't just work, but actually matters? This is the Global AI Engineer, where we move past the hype to build wiser in the age of AI. Let's dive into this story from Kigali, because it contains a lesson that the entire industry needs to learn, and learn fast.
You know, every great tragedy seems to begin with the best of intentions. And the goal here, well, it was undeniably noble: to use the most advanced tech on the planet to bring modern healthcare to a community that really needed it. The whole concept was, well, it was seductive. This idea of a single, powerful, autonomous agent that could be an all-in-one clinic manager. A digital hero, right? Sent to solve a deeply human problem. But, as we're about to see, this whole quest to build an AI hero, a solo genius, it's a path that almost always leads to catastrophic failure.
So let's really picture this. We're in Kigali, and this isn't some sterile lab with perfect Wi-Fi and endless power. No, the environment here is dynamic, it's unpredictable. The internet can just drop, without warning. The supply chain for medicine is fragile, to say the least. The stakes are literally life and death. Now, a mobile clinic is a brilliant solution for a place like this. It's agile, it meets people where they are. And putting AI on top of that, it seems like the perfect force multiplier. The promise was huge efficiency. But the reality was a deep architectural flaw. The team, as brilliant as they were, had put all their faith into one single, monolithic AI, just believing that a bigger brain was the solution to every single problem. Just think about the sheer cognitive weight of one of its tasks: diagnosing diseases. I mean, this isn't a simple database search. It requires these complex layers of reasoning, understanding the little nuances of a patient's story, weighing all the probabilities, and, this is the most critical part, having the humility to know when you don't have the answer. This one agent was expected to process symptoms, patient history, and real-time local disease data to make life-or-death diagnostic calls. This task alone is a full-time, high-stress job for a team of experienced human doctors. But for this AI, it was just the first thing on an impossible to-do list. But oh, it didn't stop there. On top of being the doctor, this agent was also the clinic's chief administrator. It was responsible for the entire patient flow, scheduling urgent follow-ups, managing the clinic's complicated calendar, and even interfacing with the drug supply chain to order medications. Each of these jobs operates on a totally different logic. You have the urgency of a doctor, the meticulousness of a pharmacist, and the organizational skill of a receptionist, all crammed into a single decision-making model. So the agent was now a doctor, a receptionist, and a pharmacist, all at once, with absolutely no way to prioritize these conflicting demands. And this just perfectly illustrates the inevitable, catastrophic outcome. Within just 2 days, the system imploded. And we're not talking about a server just going down. The failure was systemic, a total collapse from the inside out. Overwhelmed because its cognitive load was just way beyond what any single model could possibly handle. Inconsistent because trying to optimize for 3 different, often conflicting jobs led to erratic, unpredictable behavior. You know, one moment it might decide to order non-essential supplies over scheduling a critical patient follow-up, and most importantly, unsafe. An incorrect diagnosis, a missed appointment, a wrong medication order. In this context, these aren't just software bugs, they are potential human tragedies. The hero agent didn't just fail, it actually became a dangerous liability. And this is the question that just haunted the postmortem. It's the question that should be on the mind of every single AI engineer today. Why did it fail? The easy answers are tempting, right? Was the model not powerful enough? Were the tools not good enough? Was the training data biased? And yeah, all of those can be factors.
But the real root cause was much, much deeper. It was a failure of architectural philosophy. It was a failure of how we even imagine intelligent systems. And here it is, the crucial, simple truth. We would never ask a single human doctor to also be the full-time pharmacist, the lead receptionist, and the supply chain manager for an entire clinic, all at the same time. We get that specialization, focus, and collaboration are the keys to building a resilient, effective human system. We build teams with checks and balances. Yet for some reason, in the world of AI, we've become obsessed with creating this single, super intelligent agent that can do everything. That tragic failure in Kigali taught us a really powerful, humbling lesson. We have to build our AI systems with the same collaborative wisdom we use to build our best human organizations.
So, this brings us to the core of this whole explainer, this fundamental shift in mindset from building AI heroes to building AI teams. And this isn't just about changing words, it's a complete paradigm shift in how we design, deploy, and ultimately how we trust autonomous systems. It's about moving from a fragile single point of failure to a resilient network of collaborating specialists.
At my company, SIHA AI, this is our most fundamental guiding principle. A single agent, it doesn't matter how powerful its underlying model is, it's just a worker doing a task. It has a limited perspective, a fixed set of tools. But when you orchestrate multiple specialized agents, you don't just get more work done faster. You get a team. A real team that can reason and debate and cross-check each other's work and collaborate to achieve something that's way beyond the reach of any single member. In Africa, where community and collective effort are so deeply embedded in the culture, this idea isn't revolutionary. It's just common sense. Teams always outperform lone heroes in the long run because they're more resilient, more creative, and just way better at catching their own mistakes. Let's just break this down. A single agent is a bottleneck. Its entire world is defined by its context window. Its personality is dictated by its system prompt. If its main tool fails, the whole system just grinds to a halt. A multi-agent system, on the other hand, is built more like an expert surgical team. You have specialists. One agent might be the data analyst, an expert at sifting through huge amounts of information to find patterns. Another could be the communications expert, really good at translating complex data into clear, natural language for a person. A third, and this is crucial, might be the validation expert, whose only job is to rigorously check the work of the others for errors. This division of labor creates redundancy, safety, and a much, much higher quality output in the end.
Okay, so this is a really critical warning. Just throwing a bunch of agents at a problem is not a solution. In fact, without really careful design, it can create new, even more complex problems. We learned this the hard way with a microfinance system we were prototyping in Lagos. See, one agent, the risk assessor, analyzed a loan application based on financial data and approved it. But at the same time, another agent, the fraud detector, flagged some minor anomaly in the user's history and denied it. The problem was the system had no clear communication protocol, no decision-making hierarchy, so both messages were sent directly to the user. Can you imagine their confusion, getting an approval and a rejection for the same loan at the exact same time? The result was just total chaos and an immediate, and you can understand why, a total collapse of trust in the system.
And that painful experience in Lagos led us straight to our second guiding principle. A successful team isn't just a collection of skilled individuals. It's a system defined by its rules of engagement. I mean, think about a championship sports team. They don't just have talented players, they have a playbook. How do they communicate on the field? Who makes the final call on a high-pressure situation? How is work handed off from one specialist to another? Without these protocols, a multi-agent system is just a bunch of individuals creating noise. With them, it becomes a symphony. That's the difference between an amateur team and a professional one.
So how do we build these essential protocols? How do we design an AI team that actually works out there in the real world? Well, over years of fieldwork, building systems for environments with really unique challenges, we've developed and refined a simple but incredibly powerful model that we now use all across East Africa. It's a 4-agent framework that provides the essential structure for a robust, reliable, and truly collaborative AI team. Let's take a look at the roles on this team. First up, you have the planner. Think of this agent as the strategist. A user gives it a big, complex goal, like manage a mobile clinic, and the planner's only job is to break that goal down into a logical sequence of smaller, actionable steps. It basically creates the project roadmap. Next, you have the executor. This is the specialist, the doer. It takes a single, well-defined task from the planner's list, like order 500 measles vaccines, and uses its specific tools, like an API to a medical supplier, to get that one job done. It's totally focused and task-oriented. Then we have what is maybe the most important role on the entire team, the critic. The critic is the guardian of the whole system. Its only purpose is to audit the work of the other agents. Before any action is finalized or any information gets sent to a human, the critic checks it for safety, for accuracy, for bias. It's the one asking the hard questions. Is this diagnosis consistent with WHO guidelines? Is this medication order actually correct? And finally, you have the coordinator. This is the conductor of the orchestra. It doesn't do the tasks itself, but it manages the flow of work between the other agents. It makes sure that when the planner creates a task, it goes to the right executor. When the executor is finished, its work gets passed to the critic for review. If the critic rejects the work, the coordinator sends it back with clear feedback. It manages the state of the entire project. You see, this structure completely eliminates that single point of failure. Each agent has one job and it does it well. The system's true intelligence emerges not from a single superbrain, but from the disciplined, structured interaction between these specialists.
Now, having a framework of roles is a huge step forward, but it's not enough. These agents need a way to talk to each other, a way to collaborate. And in the environments where our systems have to perform, the standard solutions coming out of Silicon Valley just don't work. We can't assume there's going to be massive cloud infrastructure or constant high-speed internet. So we had to invent a completely different way for our AI teams to communicate, what we call a frugal, resilient, offline-first protocol.
The typical approach you'd see from a major tech company is entirely cloud-based. The agents are managed by a central orchestrator in some massive data center. Every single message, every state change needs a round trip to the cloud. And that works fine if you're sitting in an office with fiber optic internet. But in a rural clinic in Kakamega, where connectivity is intermittent at best, that model is a non-starter. A single internet outage could bring the entire clinic's operations to a halt. Our Frugal protocol is the complete opposite. It's designed for maximum resilience in low-resource environments. It runs entirely on-device, a single laptop, a tablet, or even a cheap smartphone. It is built on the core assumption that there is no internet. Communication doesn't happen over the web, it happens through a simple, local message queue, often nothing more than a table in a local SQLite database.
Let's walk through how this actually works, because this is where the theory becomes practice. First, all the agents share a single, local SQLite database right there on the device. This database is basically the team's shared memory. It holds the state of the whole project, the task list from the planner, the results from the executor, and the audit logs from the critic. Second, we have a non-negotiable rule for conflict resolution. If the executor and the planner disagree on something, the critic always makes the final call. This simple hierarchy prevents the kind of deadlock and user confusion we saw back in Lagos. Third, the system is designed to be humble. It knows its own limits. For any high-stakes disagreements, or in situations where the critic itself is uncertain, the protocol's only valid move is to pause and escalate to a human operator for guidance. Fourth, because the state is constantly being saved locally, the system is incredibly resilient. If the power goes out, if the device reboots, if the application crashes, it doesn't matter. When the system comes back online, the coordinator just checks the database and picks up the project right where it left off. No data is ever lost. And finally, for total accountability, the coordinator logs every single action and every handoff. This gives us a clear, auditable trail of every decision the AI team made. In Malawi, this entire protocol runs a complex agricultural advisory system on a $60 Android phone, often with no internet for days at a time. It works because, in Africa, teamwork isn't just a feature, it's a fundamental survival mechanism.
So, we've dissected the failure of the hero agent. We've explored the philosophy and the structure of building effective AI teams. Now we get to the most important part. How do you, as an engineer, a founder, a builder, apply these hard-won lessons? Your mission is to stop chasing the myth of the solo genius AI and start becoming an architect of humble, effective, and collaborative AI teams.
Here is a practical 4-step action plan you can use to get started. Step 1. Define the team roles. Before you write a single line of code, just ask, what are the distinct specializations needed to solve this problem? Resist that urge to create a jack-of-all-trades. The rule is simple. One clear role per agent. No multitasking. This is what prevents the kind of overload that caused the Kigali system to collapse. Step 2. Design the communication protocol. How will the agents talk to each other? Choose a simple local message bus. It could be Redis Lite, a SQLite queue, or any lightweight system that doesn't rely on the cloud. Define a clear message schema, and, this is crucial, set timeouts. What happens if an agent goes silent? The system has to have a plan. Step 3. Implement conflict resolution. This is absolutely non-negotiable. From day one, decide which agent has the tie-breaking vote, and it's almost always going to be the critic, and then hard-code the escalation paths. Define exactly which situations require a human to step in, making sure the system fails safely. Step 4. Test the team dynamics. This is where you move from theory to reality. Don't just test the perfect happy path scenario. You have to actively try to break the team. In Rwanda, we run chaos engineering drills, where we just randomly kill an agent mid-task. We feed the system contradictory information. We simulate network problems. If the team breaks, you don't blame an individual agent. You improve the protocols that govern the whole team.
And to make this even more concrete, here's a tool you can use today. At SIHA AI, no multi-agent system ever gets deployed until it passes our sovereign team checklist. It's just 4 simple questions you should ask of your own systems. Does each agent have one clear role? Can the team operate entirely offline? Is there a designated unambiguous conflict resolver? And does it always, without exception, escalate to a human when it's stuck? This checklist is our working definition of a trustworthy system, because a team that doesn't trust its own internal processes can never earn the trust of a human user.
There's an old African proverb that just perfectly captures the essence of this entire philosophy. If you want to go fast, go alone. If you want to go far, go together. We in the tech world are so often obsessed with speed, with moving fast and breaking things. And a single hero agent might seem faster at the beginning. It's simpler to code, it's easier to deploy. But that speed is a dangerous illusion. It leads to brittle, unsafe systems that ultimately break. To build things that last, things that truly matter, things that can be trusted with important work, you have to go together. You must build teams.
So, I want to leave you with a challenge. The next time you start an AI project, resist that powerful temptation to architect a single, monolithic hero agent. I challenge you to build a humble team instead. A team where each agent knows its specific role, respects the roles of its peers, and understands that its ultimate purpose is to serve the user through collective, collaborative, and reliable effort.
Let's leave it with this final thought. We have been sold a vision of the future of AI that often looks like a single, all-knowing superintelligence. But that vision is flawed. It's brittle, and it's dangerous. The real, sustainable, and trustworthy future of artificial intelligence will not be a solo genius. It will be a community of specialists. It will be diverse, resilient, and collaborative. It will look less like a single brain and more like a thriving, functional, and humble society, with each part working in concert with the whole. That is the future we should all be building. If you found this valuable, do 3 things to support this work. 1. Hit that like button below. It's a simple click that tells the algorithm this content matters and helps others find it. 2. Subscribe and hit the notification bell, because once you've built your team, you need to get it into the real world. Next week, I'm revealing Phase 9, Deploy and Monitor Your Agent, where we'll cover how to safely manage these teams in production. 3. Watch my latest video, Stop Calling Yourself a Prompt Engineer. Here's what a real AI engineer actually does. It's the perfect foundation for the kind of deep architectural thinking we've discussed today. I'm Marcel Masaga. Thanks for being part of the global AI engineer. Until next time, think deeper, build wiser, lead with courage.